In 1944, a 1.2 million pound locomotive hauled 3,600-ton freight trains up a relentless 1.14% grade in the Wasatch Range alone. Today, that same big boy still produces more than 6,000 drawbar horsepower, yet it no longer runs without a diesel coupled behind it. The easy assumption is the machine lost something. It did not. The entire railroad around it did. At the height of World War II, Union Pacific's Big Boy 4014 confronted a challenge measured not just in miles, but in gravity, mass, and endurance. The Wasatch Range east of Ogden, Utah presented a relentless 1.14% grade, an incline that stretched for more than 70 miles, climbing from 4,300 feet at Ogden to nearly 5,800 feet at the summit. Over this climb, the Big Boy was tasked with moving 3,600 tons of freight, a figure dictated by wartime demand and codified in dispatcher logs and ALCO's official specifications. Each run meant the locomotive's 1.2 million pounds of articulated steel, spanning a 488 four-wheel arrangement, had to generate enough force to keep a train of nearly 3 dozen loaded cars rolling upward without pause. The target was clear: maintain 25 to 30 miles per hour, even as the grade bit into every ton. Engineer trip reports from 1944 show that number 4014 routinely held 27 miles per hour on the steepest stretches, sometimes surging to 32 on the easier curves before the summit. These were not isolated feats. They were expected, repeated, and recorded in the daily rhythm of wartime logistics. The locomotive's power output was as formidable as its bulk. Drawbar horsepower exceeded 6,000 under load, with dynamometer tests confirming that the Big Boy could deliver more than 135,000 pounds of tractive effort at the rail. This was not theoretical strength, but measured reality, enough to keep the 3,600-ton train moving at speed, even as it consumed thousands of gallons of water per hour and demanded fuel oil stops every 150 to 200 miles. Crew discipline was essential. Engineers opened the throttle wide at the base of the grade, then feathered it back to prevent wheel slip, while firemen kept the boiler's firebox roaring to sustain the 1,650 gallons per minute evaporation rate required for the climb. On the Wasatch, every ascent was a calculated contest between machinery and mountain. The Big Boy's massive air compressor pushed 2,200 cubic feet per minute to maintain brake pipe pressure, while the locomotive itself bore the full responsibility for traction, braking, and momentum. No diesel in sight, no backup waiting in the wings. The numbers alone tell the story. 3,600 tons, a 1.14% grade, 25 to 30 miles per hour, and a locomotive that weighed more than a fully loaded Boeing 747. In 1944, nothing else on rails could match it. The solo performance was not a myth or a marketing boast, but a daily reality, backed by the unyielding arithmetic of tonnage, grade, and horsepower. Beneath the spectacle of Big Boy, 4014's solo climbs in 1944 ran a vast coordinated system that made such feats possible, a network as critical as the locomotive itself. Along the Wasatch Range, the Union Pacific maintained a chain of water towers, each spaced about 30 miles apart. These towers, like the one at Hill Creek, stored up to 14,000 gallons, and their locations were chosen to match the relentless thirst of a locomotive evaporating over 1,600 gallons of water every hour. The tender's 23,500-gallon capacity demanded regular stops, and wartime schedules accounted for this rhythm. At each water stop, sand houses stood ready, holding tons of traction sand for the next steep climb, while coal or oil depots like the massive 20,000-ton dump pit at Shannon ensured that fuel was never more than a few hours away. Servicing points were equally essential. The Ogden Roundhouse, a 6-bay structure at the base of the grade, operated around the clock. Crews could swap out worn bearings, clear ash from fireboxes, and send a Big Boy back out within hours. At North Salt Lake, a 6-track ash pit handled the nightly buildup from dozens of steam runs. Maintenance wasn't a matter of convenience, it was a necessity, dictated by the heat, pressure, and wear exacted by every loaded mile. But the infrastructure was only half the story. The human system was just as intricate. Wartime operating orders called for rotating 2-man crews, engineers and firemen, at scheduled stops, often coinciding with water refills. While dispatcher logs confirm changes at Ogden and Provo, oral histories recall Hill Creek as a place where crews would sometimes swap, using the pause to check bearings, refill sand, and inspect the running gear. Each crew was trained to manage the full cycle of a mountain run. Open the throttle wide at the base, feather it back as the grade steepened, and keep the firebox roaring to sustain the relentless demand for steam. Schedules flexed to accommodate these realities. Dispatcher boards left room for unscheduled delays, an extra 10 minutes for a stubborn injector, a quick inspection at a siding. The entire railroad bent itself to the needs of the steam locomotive, with yardmasters, signalmen, and maintenance staff all attuned to the big boy's progress. Every ascent depended not just on horsepower, but on this web of support: water, fuel, sand, skilled hands, and a timetable built for steam. Without this system, even the most powerful engine would have been stranded on the grade, its strength rendered meaningless by a dry tender or a missed crew change. In 1944, the big boy's solo runs were not a matter of brute force alone, but the visible tip of a deeply interconnected operation. Federal law now defines every aspect of the big boy's operation. The Rail Safety Improvement Act of 2008, written after a string of deadly mainline accidents, made positive train control mandatory on all Class I main lines. For Union Pacific 4014, a machine built long before digital systems, direct compliance is impossible. The Federal Railroad Administration allows historic steam engines to run without onboard PTC when the host railroad secures a formal waiver and files a detailed excursion operating management plan under 49 CFR 236.1029B. Union Pacific's plan, approved by the FRA, requires a trailing diesel to serve as the PTC host. The diesel's computer, cab signals, and radio link form the train's only legal connection to the digital safety network that now controls authority, speed, and block occupancy. Dispatchers assign each excursion a strict window, often just 30 minutes, inside the railroad's traffic management system. This is not a favor, it is a legal mandate. Any unscheduled stop or delay can trigger a PTC violation, halting traffic until the system is reset. Union Pacific's bulletins cited in the 2026 waiver require a certified PTC safety officer in the diesel cab ready to intervene if the digital link fails. If the diesel loses PTC lock, the train must stop immediately. Liability coverage is equally uncompromising. Each main line run demands at least $50 million in insurance, meeting FRA rules and covering every possible incident. Only PTC-certified engineers may operate the diesel, and the steam crew must hold credentials approved by both Union Pacific and the FRA. These protocols are non-negotiable. Without them, the big boy would never leave the yard. Big Boy 4014 still commands respect with over 6,000 drawbar horsepower and tractive effort that few modern locomotives can match, but raw power alone cannot meet the demands of today's mainline. The diesel helper trailing behind is not just a nod to convenience, it is a practical answer to engineering limits the steam era never solved. Braking is the first hurdle. Big Boy lacks dynamic brakes, a technology that lets diesel electrics transform momentum into electrical resistance, sparing air brakes from overheating. In the 1940s, crews managed with careful air brake handling and frequent stops to cool brake shoes. Now, with longer trains and tighter schedules, the diesel's dynamic brakes absorb thousands of horsepower in retarding force. keeping grades safe and brakes intact. Water and oil consumption pose another challenge. Big Boy burns through over 1,600 gallons of water per hour and needs oil every 150 to 200 miles. The old network of water towers and oil depots is gone. The diesel extends range, hauling auxiliary water and ensuring the train is not stranded between stops. Air brake supply is another legacy constraint. The original compressor, rated at 2,200 cubic feet per minute, was built for shorter trains. On today's longer consists, the diesel's compressor maintains steady brake pipe pressure, preventing emergency stops. The diesel also supplies hotel power, reduces wear on Big Boy 4014's historic machinery, and stands ready as backup. For the maintenance crew, this partnership means fewer breakdowns and a longer life for the world's largest operating steam locomotive. The diesel does not diminish the Big Boy's strength, it preserves it. Big Boy remains a 1.2 million pound powerhouse, but the railroad it once conquered no longer exists. Today, diesel helpers bridge the gap left by vanished water towers, oil stops, and steam-era practices. The irony is clear. The machine endures, but its world has moved on. What do you think?